Hello everyone and welcome to yet another recreational programming session with Mr. Zodin. So today I decided to take a look at this legendary library, which is called Asio. Right, so I suppose it's basically abbreviation from asynchronous input-output, so it's Asio. We're gonna call it Asio. So, and I knew about this library, I think, since forever, since I even started programming in 2006, but maybe I don't know when it was released, but I feel like I knew about it forever. Right. So, and I know about this library from the times when I considered that programming in C++ is only achievable by true hackers or something like that, and it was like admiring people who can understand how to use Asio and stuff like that. And I did a lot of different things throughout my career, including professional programming in C++, but I never really touched this library. Never had an opportunity to even touch this library. And I think since I'm a streamer who kind of reviews different libraries now, now it is an opportunity to finally look inside of this library and look inside of this legendary library and try to use it for something, right? So, and that's going to be the topic of today's stream, right? We're going to be looking into this library. We're going to do a blind run, right? So, like, I haven't looked, as far as now, I don't even have it installed, right? So, I kind of was going through installed packages on my system because I need to clean up some space. And I realized, like, I stumbled upon a boost package in the system, and also looked if I ever have like Asio and stuff like that. And apparently Asio is kind of a little bit weird. It has two variants. It has a boost variant and non-boost variant. And as far as I know, there's not that much difference between them. Like, look at that. They even have documentation, non-boost and boost. Right, so I'm not really sure which one I want to install, but I feel like I want to install a non-boost one, because a non-boost one has just like less dependencies. It doesn't depend on boost, I guess, right? So we can even take a look at it. Asio boost versus non-boost. Nope, not nob, but non-boost. So let's actually take a look at that. So yeah, so they even discussed that on their website, on their official website. Asio boost and non-boost. Okay, so what do we have in here? So Asio comes in two variants: non-boost Asio and boost Asio. The difference between the two are outlined below. So Asio is in a namespace called Asio, whereas boost Asio puts everything under boost Asio. For those who don't know, Boost is sort of like a collection of different libraries, which I suppose is developed under different projects. So it's more like a Apache for C++. Do we have any professional C++ programmers in here? Can you confirm that Boost is basically Apache, but for C++? It's just like this sort of like an umbrella project, which includes a bunch of libraries that everyone sort of donates to them. Do I understand it correctly? Like, I don't know. So that's actually accurate. So it's basically an Apache for C++. Okay, so Boost is an Apache for C++. So, right. The main Asio header file is asio.hpp. The corresponding header file in Boost Asio is boostasio.hpp. All other headers are similarly changed. So as you can see, so far changes are just in the naming. Any macro used by or defined in Asio are prefixed with Asio underscore. In Boost, they are prefixed with Boost Asio underscore, and so on and so forth. So interesting here is that Boost Asio always uses Boost system library to provide support for error codes. For C++ 11 and later, Asio uses std error codes. So yeah. So Asio is a header only, and for most users does not require linking against any Boost library. When using C++ 11 or later, with a recent version of GCC client MSVC, Asio can be used without any dependencies on Boost. So I feel like the only difference is that just naming, right? Naming on different variables, right? Apart from that, it's literally the same library. And I kind of want to go with just Asio, because that's the thing I have on my system in Void, right? So if I try to search specifically for Asio, I don't have a Boost Asio, right? I specifically have just vanilla Asio. I can even take a look at like a description of this entire thing. So it refers to the official website, not the Boost website, by the way, the official website of the developers. And So if you take a look at the files that we have in here installed in the system, so all of that is just header files, right? So all of that is just header files, and I don't think I have any binary files in here. So there's something like IPP. I don't remember what is IPP. IPP is sort of like a precompiled headers, if I'm not mistaken. Right, so IO-uring, there's some IO-uring in here. That's pretty cool. And also there is a package config stuff. Okay, that's pretty cool. All right, so let's actually go ahead and maybe install, you know, Asio, and let's actually see if we can use it for anything. So I'm going to install Asio, and yeah. So I'm not going to be downloading it from official website. I'm just going to be using whatever comes with my system. So let's go into the probe, and I'm going to put Asio in here, and I'm going to try to remember how to program in C++. Does anybody remember how to program in C++? Like, I remember that all of the C headers have to be prefixed with C without .h, right? So, and then you create something like this, and then you use printf. Right, so hello world, and that's basically idiomatic C++ program, if I understand. No, it's not idiomatic. You have to put std : Is that so? This is a perfect idiomatic C++. It's also written in a Morse. So idiomatic one is cout. So as far as I know, in the latest C++, you have println. Right, if we're being serious, right? So if we're being serious, as far as I know, the latest idiomatic thing is just this. Right, so, and if I do C++ println, we can actually just Google it up. Right, so println, I don't remember the... Seriously? Am I being man-in-the-middle right now? Can anybody confirm that CPP reference is not hacked or anything? I swear to God, if it's fucking Russian government just trying to man-in-the-middle me right now, they do that from time to time, by the way. They do that from time to time. C++ itself, okay, I don't get the warning. Fuck. This is my freaking government. Okay, so I suppose I'm gonna just steal that from here. It's actually print. Yeah, you are being man-in-the-middle. Okay, so they do that from time to time, by the way. They do that from time to time, so it happens. So don't worry about it. You are seeing KGB at work live. If you ever wondered how KGB works, there you go. You're witnessing it live. That's the reality of living in Russia right now. So at any point, KGB can just start to man-in-the-middle in you. Just saying. So they're probably watching us right now, by the way. So they're probably watching it. Hello, Tavarish Mayor. Hello, hello. So let's try to compile this entire thing and see how what we can do in here. So maybe I'm going to use makefiles, by the way. So main CPP. So what should we use? Should we use GCC or should we use Clang? Right, so let's actually maybe use G++. Right, so I'm going to use G++. Baba G++. So let's do make and let's fucking go. Println is not a member of std. Ha. Is that because I have to explicitly say std C++23 or something? Yes. That's exactly the reason, right? So are we going to be using C++23, right? I think it's a good idea to use C++23, just to be on the cutting edge, right? So just to be on the cutting edge. All right, so I'm going to try to run this entire, and there we go. So here's the hello world. Isn't that amazing? Modern C++ is freaking amazing, mate. Fucking amazing, mate. Anyways, so as far as I can tell, right? So we already installed Asio. So here is the Asio, and as you can see in here, we even have a root of include asio.hpp. So let's actually take a look at what we have in that specific header. So, okay, so that's a very simple copyright and stuff like that. Includes a bunch of, that's a lot of fucking includes. It includes, oh, it just includes everything, okay. So so we can take a look at the version.hpp. So what do we have in here? You can actually see the version. You can compare version and stuff like that. It's actually rather clean. Wait a second. Why is it so readable? Okay, so append T, completion token type used to specify that the completion handler argument should be passed additional values after the result of the operation. Completion token. Ha. Oh, variadic templates, by the way. I know about this thing. Variadic templates. Oh boy. Welcome to C++, I suppose. I really like this private, which is kind of commented out. Why is it commented out? Right, so it's like they really needed an access to these fields, so they originally kind of wanted to make it private, but then it's fuck private, whatever. This is kind of funny, like I don't really know what's up with that. But anyway, so what we can do in here, we should probably just include Asio. So Asio, and we're gonna try to just compile this entire thing. Damn. It took 3 seconds to, like almost 4 seconds to compile. Okay, so just a second. What if I exclude this thing? Okay, so it's 1.3. 1.3. I'm including Asio. The time triples. All right, let's fucking go. So I hope KGB is already done. Oh yeah, it's done. So look at that. So we shamed KGB agents a little bit, and they actually stopped man in the middle. I'm telling you, they're watching us. You think I'm joking? You really think I'm joking? They're watching us right now, right? So they just decided to mess with us a little bit, right? So that happens from time to time. That happens. Say hi to the KGB agent. So anyways, is there any like maybe examples on how to do this kind of thing? So I suppose this is a asynchronous input-output library, right? And as far as I can understand, it's sort of like designed for doing networking stuff. So, and because of that, we can do sort of like a Raylib speedrun of networking libraries, which is basically an asynchronous echo server, right? So does that sound like a cool idea? Right, let's actually establish the scope of today's stream. Let's try to develop an asynchronous echo server, and let's try to deploy it to your mom, and let's just see if it's accessible or not, how pleasant it is to use this library to develop this kind of things, right? So anyway, let's take a look at the HTML documentation and see what we can do in here. Okay, so let's start with an overview. Is this just an overview? This is just an overview. Okay, so I'm not really sure what I'm looking at, but anyway. Rationale. I don't want to read any of that, so I suppose I'm going to skip that. Basic Asio anatomy. Okay, your program, IO object, for example, socket. Execution context, right? So there's some sort of an execution context, and within that execution context, you create sockets. All right, so that's a regular sort of like a synchronous library situation. So your program will have at least one IO execution context, such as Asio IO context object, Asio thread pool object, or Asio system context. That is very interesting. So there is 3 kind of execution. That's very interesting. It kind of reminds me to like these are just runners. There are different runners for the objects, right? So here IO context is probably asynchronous stuff. Here is for threads instead of like sort of green threads, and system context, I'm not really sure what's up with that. This IO execution context represents your program's link to the operating system IO services. Okay, so let's actually try to maybe create IO context, like literally. Okay, so since we must have at least one IO context, let's try to create it. Okay, so we managed to create it. We can try to run it, right? So, and it executes, right? So it didn't create anything, right? So, but I suppose it just allocated the object, run the constructor, and so on and so forth, right? So precompile the header. I have no idea what that's supposed to mean, right? So how do I precompile the header? So I suppose precompiled headers are IPP, right? So that means I have to include IPP, PCH, right? I saw some IPPs in there. Right, so Asio, yeah, so I don't know, there's some ACHP, whatever. Anyways, let's continue, please, let's continue. To perform I/O operation, your program will need an I/O object such as TCP socket. Okay, so let's create le TCP socket, le socket. Okay, so that's pretty straightforward so far. Right, so will that compile? So let's actually see. Will that compile? That seems to be compiling, right? So we created an execution context. Within that execution context, we created le socket. I would like to maybe take a look at what those things are. Isn't it interesting, chat? Isn't it interesting what those things are? Can I just grab for something like class IO context? What is it? What is it? Okay, so I can see IO context in here, and I suppose this is where it is. There's a little bit of a documentation in here, and I suppose this is documentation that is picked up by some sort of automatic documentation tool like Doxygen. Is that a Doxygen? Like, I'm not really sure. Maybe it is Doxygen, but anyway. So provides core IO functionality. The IO context class provides the core IO function. Okay, so you said that twice already. For users of the asynchronous IO objects, including socket, acceptor, UDP socket, deadline timer. Okay, I suppose acceptor is a server, right? And it creates the connection sockets and stuff like that. The IO context class also includes facilities intended for developers of custom asynchronous service, thread safety. Okay, so this is nodes for the thread safety and stuff like that. Synchronous and asynchronous operations. Synchronous operations on IO object implicitly run the IO context object for an individual operation. Okay, I feel like it's a little bit too early for me to try to read all of that, right? So I think it's a little bit too early. It goes a little bit too deep into the details, so I'm gonna just actually kind of avoid that. So when synchronous connect operation is performed, the following sequence of events occurs. Your program initiates the connect operation by calling the IO object. So socket connect server endpoint. Aha. So here we are actually describing the client. So I can try to maybe connect. So socket connect, and here I'm supposed to provide server endpoint, but I'm not really sure what server endpoint is. So I'm gonna put a boba in here and let the compiler fail. And since it's a C++, it's probably going to generate a huge ass error. Fucking classic. Okay, so no matching function for connect const char 6. We have a bunch of candidates. So endpoint type with protocol executor blah blah blah. So different basic endpoints, right? So it's basically we need to provide some sort of an endpoint. So something called endpoint. So maybe we can go into here, and since all of the classes are kind of organized in their corresponding names, for example, IO context, as you can see, so we have a class IO context, and there is a corresponding file IO context. I'm gonna assume that maybe there is something like socket, right? So HPP. So, and the socket, look at that. So it's located within IP TCP socket. So that means here we should have something like IP. Here is the IP folder, then TCP, and it's like a single file, and there should be something like a class socket. Okay, so I think it's, yeah, so here is the class TCP. Aha, right. So I really appreciate that they keep this structure, which makes it kind of very easy to explore things. I really appreciate that. So, okay, so there is a type def endpoint and stuff like that. So, and within this thing, there should be something like socket. And socket, okay, I can see that. So it's basically an inner type within the class TCP, which is rather interesting, right? So why they decided to organize it like that, but I mean, sure. So I would expect it, I thought originally that it is maybe some sort of a namespace, but apparently it is a class. C++, am I right? C++. Anyways, so, and yeah, so within this thing, socket, so that means this is a basic stream socket. So maybe there is a basic stream. So basic stream socket. Did I lose it? Yeah. Basic stream socket. So maybe if I try to grab for this entire thing, so here it is. Basic stream socket. Basic stream socket. Okay, so there should be something like connect. Do we have something like connect? Where is the connect method? I don't see the connect method. So it's probably not in here. It's in some sort of a parent or whatnot. OP, am I right? So anyways, okay, so let's actually continue reading. So the IO, like when you do connect, right, I was hoping to find how to create the server endpoint very quickly just by analyzing the source code, but I mean, it requires going to too many places, so I'm going to actually abandon that and continue reading this entire thing. The IO object forwards the request to the IO execution context. Okay, the execution context calls on the operating system to perform the connect operation, understandable. The operating system returns the result of the operation to the execution context, very cool. The execution context translates any error resulting from the operation into the object of the type error code. An error code may be compared with the specific values or tested as a boolean, where false result means error, and so on and so forth. So the IO object throws an exception of type, it throws an exceptions. So Asio throws exceptions when something bad happens. Okay. So if the code to initiate the operation had instead been written as this, the error code variable EC would be set to the, okay. So it has overloaded, that's kind of interesting. So you have an option. If you just call with server endpoint, it will throw an exception. But if you supply error code, it will set error code. And notice how we don't supply error code by pointer or anything like that. And this is because it probably uses C++ references, right? So we're passing it by references, so it will set it. Okay, so it's kind of cool that you can basically disable exceptions if you want to actually sort of like catch them. It's kind of cool. I really like this design. Okay, so your program initiates the connect operation by calling the IO. Okay. So, okay, so I see. When a synchronous operation is used, a different sequence of events occur. So this is specifically for synchronous stuff, right? So what we're doing right now in here is just asynchronous stuff, right? All of that is synchronous. When you want to do something asynchronous, right, you do your completion header. They are using fucking callbacks? I hope this is not the only option to do asynchronous stuff. Okay. They're literally using callbacks, chat. They're literally using callbacks. They have C++ coroutines. Okay, so we'll get to that, I suppose. We'll get to that. Yes, so the exact signature required depends on the synchronous operation being performed. Okay, so that's understandable. I suppose somewhere here you also have to start some sort of a loop. Right, so this is just an overview of how generally this entire thing works. They don't give you much details, right? So they don't give you much details, and yeah, so what's important is that you have a context and you have different objects that operate within that context. Understandable. Cool. So this is just the basic. So then we have an asynchronous model. Asynchronous operations. Okay, so can we have some examples, please? I got bored reading all of that stuff. So can we have some examples in here? So using a timer synchronously. So basic skills. I really like how they call that skills. Interesting. So it's kind of interesting. Imagine inventing just a library and then calling just being able to use that library as skill. Interesting. So, okay. So what we have in here, so this is a context, right? This is a context. Then we have a steady timer, right, within that context. And then this is like basically 5 seconds. And then we wait. We can try something like that, right? So we're not gonna start with the sockets or anything like that. Asio steady timer. So this is a steady timer. So here it is. This is IO context. Right. Maybe it makes sense to actually also call it IO because it's kind of shorter. So then you have Asio Corona, and in here we have seconds, right? So this is the seconds, and this is going to be 5 seconds, right? So they use 5 seconds in here. And if I just run it as is, I suppose it's not going to do anything, right? It is not going to do anything. So by itself, the compilation already takes 3 seconds. So you don't even need to run the program, by the way. You don't even need to run the program. The compilation is long enough for you to wait. Okay. Like I couldn't tell when it's starting doing things. All right. So we can do something like println, waiting for 5 seconds. Right, so here maybe we can do something like seconds, and this is going to be 5. We can put seconds in here, and then I can say seconds like that, and then println done. Done. Okay. Oh, it didn't println. Oh, because it has to be std. I apologize for that. So it has to be std. Ayo. All right, so waiting for 5 seconds, right? So we're waiting for 5 seconds. That's pretty cool. Done. Okay, cool. So we now know how to do the timers. So, but this is a synchronous timer, which means that it basically blocks this call, right? And that's it. So you can't really do anything until the timer is done. So the point of asynchronous stuff, I suppose, is that you can do something in the meantime. And since they're suggesting to use callbacks, okay, so that's very interesting. And it's literally like a different operation in here. So it's up to the object to decide whether to do a synchronous or asynchronous thing. Okay, and here is the loop. Remember how I said that there should be something to sort of start the loop for like asynchronous operations? Here it is. You start the loop using the context. It really reminds me the library that we were developing, C3 FOT. Do you guys remember? Do you guys remember me developing this library? So I was developing futures for library in C3, right? And I'm gonna put that in the description and stuff like that. And we literally kind of reinvented the same design. We ended up having different kinds of runners. We didn't call them context, we called them runners. And then we had futures and different kind of objects that worked within the environment. But it was up to the environment to sort of run them, right? And we can even take a look at some of the examples in here, I suppose. So Echo server, for instance. So here's the Echo server. Yeah, and what you would do in here, so here's the TCP server socket, and then, so this is the socket, you just create like a TCP server socket, and then we have a runner, and runner I think is a global object somewhere in here. I wonder where it is. Here you go, and it's a poll runner. So, and runner is the context, right? So, and then at the end you would do runner run, literally the same thing you would do in here, IO run, because it contains the event loop. So it's kind of cool. I really like that. You kind of come to the same sort of design of the library, right? If you try to solve the same problems. Okay, so, and let's actually go in here. So this is a wait. We're going to do async wait, right? So this is a async wait. And in here, you're supposed to provide the pointer to the function, right? So they suggest you to use the pointer to the function, but can we just use the lambda, right? So this is how you do lambda in here. Can I just have something like that? But then I'm going to put done in here, right? So let's actually try to recompile the whole thing. Let's try to recompile the whole thing. And it didn't even work properly. So what does it say? So no matching function call for lambda. So basic waitable timer wait. So you can't, it has to be a function. Really? So, and this is a print. Oh, it's supposed to accept an error code. Maybe that's the problem in here. So we can try to accept, like specifically this std error code. They're using the error codes from the standard library. Okay, so let's give it a try. And that should compile, hopefully. Okay. It's just, the problem was that the lambda is supposed to accept something, right? It's supposed to accept an error code. So maybe we can try to like print error code. So just to see if there was any error in here. So this way we can actually catch an error. Okay, so here's the interesting thing. We just do asynchronous fuck. Okay, you can't print this entire thing because it's probably not printable. Static assert failed. The formatting must be specialized for each type being formatted. So there's no formatter for error code, which is kind of weird, isn't it? Considering that it is from the standard output. Right, so you should be, I think you should be able to print it with println. Like, I'm pretty sure about that. So std error code, maybe I should include something to have error codes in here. Yeah, something like system error. Ewhat, maybe I have to do ewhat, but I want to try something first, including system error, right? But I feel like maybe asio.h already includes that for me, so that shouldn't be a problem. So that shouldn't be, yeah. I really like C++ errors. It's just like it barfs like nonsense at you and you're trying to decode that and it's just like holy shit. Okay, so error code, you guys say there's something like what in there, right? So, but that's a lie, by the way. Somebody in the chat said you can do .what, but there's no what in here. There's a message though. I guess member functions, right? So here's the message, and yeah, so we can try to do a message. Can I do a message? Right, maybe inherence what, maybe, I don't know. So, and it's apparently a function, right? So we have to do something like this. Honestly, like it's already 4 seconds, by the way. I really like C++ compilation times. I change a little bit and then I just like go and sip my water, right? So it kind of reminds me the times when I worked as a Java developer. It's just like I can ponder at a problem, make a little bit of a change, compile and go drink some coffee. So it's just, goal is 30 seconds, I say. So. All right, so, and if I try to run this program, by the way, it will say waiting for 5 minutes and then it will instantly exit, right? So, and this is because it didn't actually run any of that stuff. It just kind of scheduled it somewhere. It probably has somewhere a table and it just scheduled that operation that we asked it to do. So what we have to do, we have to actually run the event loop of the context, right? So let's go ahead and try to do that and see what is going to happen. And it says error code success. So what's cool in here, if I understand correctly, is that we can actually start several timers simultaneously, right? So here we can say this is a timer 1, right? So, and we're kind of running the timer 1. So let's actually group them like this. So interestingly, I'm really thinking, so what if I want to like start several timers? If I try to do them in a loop like that, what is going to happen? Because the timer is created within this particular scope, so that means it's going to be destroyed when we go to this context. Will it actually fire if the timer is destroyed? This is a very interesting question. I'm actually curious. Right, so I'm gonna create this kind of thing in the scope. So that means outside of the scope, this object is going to be destroyed. Is it going to do anything? So let's go ahead and try that. So that means we have to make sure that all of these timers, they... Oh! That is nice! So it will error out with the operation aborted. Nice! So that means this function, this callback, can be called when this object does not exist anymore. That is cool, isn't it? I think that is kind of cool. So that means I have to maybe... so if I want to have like several timers in here, maybe I have to have something like std vector. Right, so and in here that obviously has to be a vector, so this is going to be std vector. Within the std vector we're going to have something like a timer, and this is the timers. Right, so and what I'm going to do in here is just like I'm going to be iterating all these timers. Right, so I'm going to say I'm going to have maybe 5 of them. Right, so this is going to be 5 timers. Instead of using seconds, we're going to be using literally I in here like that. And so I'm just creating the timer. I'm just creating the timer, and then I'm just doing timer pushback in here. So I suppose what it does, it transfers the object here. How can I move that object there? So does anybody remember? So in vector, there was something like a place back or whatever. I don't want to copy that object. I want to literally move it. So in place, yeah. So something in place back. In place back. So let me see how we're supposed to use that. So appends a new element to the end of the container domain of construct, which typically uses placement new to construct blah blah blah. So in place back like this. So is it going to be moved, or can I just use you know, std move? Maybe place before run. So but because of that, pushback, does pushback return? It doesn't really return anything, right? So it doesn't really return anything, but pushback has a move variant, so I feel like what I have to do is just like do move, right? So that's what I have to do, and move is essentially what's the signature of move. Man, move semantic, like I'm gonna like prize Rust a little bit. One thing that Rust did right is probably move semantic, right? Checking move semantic at compile time is something that C++ should have probably done. Right, so it's just like in Rust, move semantic is much fucking easier, right? Because it's like if you're doing something wrong, it's just not gonna compile. Right, it's just simply not gonna compile. But in C++, it may not move, and it's gonna do that silently without telling you anything. It's just like, holy shit. So anyway, and I suppose like this is how I say that, right? So basically move this thing, right? So basically move this thing, and it's going to be inside of these timers now. And yeah, so let's just go ahead and maybe try to compile it and run it and stuff like that. Okay, so as you can see, we run 5 timers with different times, and we fired them simultaneously. That's the interesting thing. We fired them simultaneously. And then they started to get finished each second, because they have different sort of like, you know, lengths. So that's what's going on here. And I wonder if we can even print in here. So something like done waiting, awaiting, so seconds. And I actually want to get I, but I suppose I won't be able to get that I, right? So because it means I have to capture it. So it's not going to compile. Yeah, it is not captured. But if I try to capture it by reference, it's going to, the object, this particular lambda is going to outlive I. It is going to outlive Y, so actually the reference is going to be invalid, right? And I suppose this is not a good idea to do that. By the way, I should probably not start it right away. I should not start it right away. So it's not a good idea to do that, even though it will compile. But I suppose this reference, which is going to be stored in this closure object, is going to be invalid. Do I understand that correctly? So what I should do in here instead, I should capture it by value. Is this how I capture it by value? Right? So that's probably what I want to do in here. I want to literally copy the whole thing. So I understand everything correctly. So I kind of remember how C++ works more or less correctly, which is nice. So and now, if I try to run it, so as you can see, we are using the value. We're sort of capturing the entire value, right? So that's pretty cool. So that's pretty cool. That's pretty cool. So does this look like a real C++? People, like every time I program in C++ and I like to program in this like a C with classes style of C++, a lot of C++ fans come to my comment section and say, oh, this is not a real C++. This is not a... Is this a real C++? Look, it has shit ton of colons. We're using closures. We're doing captchas, we're using references and stuff. This is a real C++. Is this a real C++? Because I can't tell, right? So, okay, cool. So I'm doing a real C++ now. Anyways, we're even using move semantic. It is as real as it. No array. Well, I mean, we're using array, right? So essentially, so all of these contexts and timers are getting cleaned up by the destructors. So that's array AI. It's as array as it can get. Anyways, so that's pretty cool. So we know how to do timers, Alzheimer's, and stuff like that. The timer Alzheimer's, basically it forgets to fire after some time. Timer Alzheimer. Oh shit, somebody should create. Anyway. So, binding arguments to completion handler. Binding arguments to completion handlers? What is that? What year is it? Is that a C++ 03? We have lambdas. We have lambdas. I guess all of that is coming from the times when it's just like we didn't have lambdas, right? So, stdbind, isn't stdbind like an old ass function? It is insanely old. It's literally before we had lambdas. It's literally before we had lambdas. Yeah, it's insanely old. So yeah, I don't think it's like, this is an old documentation. Even I, the C guy, right? Even I, the C guy, know that this is old shit. Right, so and I suppose, well, we literally did that. We literally bind some stuff and yeah, we don't care about it. Using a member function as a completion. Ooh, that's very interesting. Using a member function and you're just binding this. Okay, so like we don't care about that either. Those tutorials are kind of lame, honestly. So synchronous completion handlers in multi-threaded programs. Do we want to go into multi-threading? I kind of want you to do asynchronous stuff, not really multi-threaded stuff. So I think so I suppose you just use a different context for this kind of stuff. No, it's not really, right? Yeah, so you even use the standard threads in here. So I don't really want to go into multi-threaded stuff. stdbind sucks though. It kind of does, right? So because it's kind of limited, right? It's from the times when C++ was much limited. I don't think you need it right now. I don't think you need it anymore. Okay, so basic skills. I suppose we kind of acquired basic skills. So let's go into the sockets. Le socket. So the tutorial programs in this section show how to use Asio to develop simple client and server programs, and this is exactly what we want. These tutorial programs are based around the daytime protocol, which, this is actually kind of cool. Is that a new, this is a kind of cool hello world for this kind of stuff. So the RFC specifies the standard for ARPA Internet Community Host, but useful debugging. Isn't that? It's the, I think I remember that. I think I remember this protocol from Last Mile's streams, right? So it's just like literally you accept the connection and you send them a string with the current time, and even the format of the string is not particularly specified. It's just like you have to do something, right? So you just have to respond with the current date time in whatever format you want, roughly. There is no specific syntax for the datetime. It is recommended that it to be limited to the ASCII, and ASCII even just recommended. So space carriage, return, and line feed. The datetime should be like this. And there's a literal standard for that. There's a literal standard for just accepting a socket connection, responding with a string which tells you datetime without any specific syntax, and just closing the connection. There is an RFC for that from 1983. Man, the internet in the 80s was much simpler, right? So this is really funny. There's like little RFC for that, and it's so goddamn fucking short. Look at that. So I really like that. It's kind of cool. But it's cool like a hello world for networking stuff, right? So it's really cool for hello world as a networking stuff. So I'm gonna put it in here. Okay. So let's do a synchronous datetime server. Let's actually start with the server, because client, you can just use a telnet as a client, right? So you don't really need to do anything specific for the client, right? So just like a telnet and you get that. So this is going to be synchronous TCP datetime server. So the first thing we're going to do, okay, so here is the stuff, and here I might as well actually timers example. So this is going to be timers example, and I'm going to just do timers example. And here datetime server, and it's going to be just datetime server CPP, and we're going to just compile it with this kind of stuff. So all we're going to be compiling all of these things. I'm not really sure if I want to compile a timers example, because it takes like 3 or 4 seconds, right? And I'm not going to be running it anymore. So because of that, I think I'm not going to compile. So I want to replace these two things, datetime server, datetime server. Okay, so let's open this thing, let's put it in here, and let's include the usual print. Asio HPP, and it's going to be main, stuff like that, return 0, print ln. Well, we're going to start with Asio IO context, context IO. I think I'm getting a hang of this library. I kind of like it, honestly. So hello Asio. All right, so let's try to compile the whole thing. One more time. Okay. So when you try to compile something, Emacs will ask you to basically save all of the files that are unsaved, just in case those files are used in actual compilation process. Okay, so we have the context, and what we have to create is an acceptor, and this is how you create an endpoint. That's kind of cool, right? So this is the endpoint. You can specify the version of the TCP protocol, and I suppose, I'm not really sure what that is. Is that a port? This is a port. Man, dude, this is such a small port. I didn't even recognize it as a port number, because right, again, it comes from the 80s. The internet was much smaller and simpler, and people were just casually using port 13. Vintage port number, yeah, exactly. Vintage port 13 though. Damn. Very unlucky number. Very unlucky number. Okay, so let's actually do acceptor, daylight server. So TCP. So what they're doing in here, by the way, they're using a little bit of using, right? So yeah, look at that, look at that. So they're using using, which probably makes sense, because if you start doing stuff like that, that's a little bit of a cancer, not gonna lie. That's a little bit of a cancer. So maybe what we want to do instead in here is actually using. Yeah, that's right. And on top of that, maybe I should do using namespace std. Will professional C++ programmers yell at me if I do something like that? Is that something forbidden? Right. Yeah, so they will yell at me. Luckily, I'm not a professional C++ programmer, so I can do that. I'm joking, I'm not going to do that. So what I'm supposed to do, if I understand correctly, I'm supposed to just import a specific name like that. Right, so this is correct. Right, this is correct. Okay, so we have to create an acceptor. And how do they call acceptor in here? They call it They just call it acceptor, believe it or not. But can I just call it server? I kind of like calling it server. So TCP endpoint, right? So I'm specifying the endpoint, and I have to do that within the context, by the way. So an endpoint TCP version 4, right? So we're using the latest standard of IP, and then we have to specify the port, right? So maybe it makes sense to actually put the port to here, and it's going to be 13. So this, I'm going to be listening to 6969 because I'm pretty sure my operating system won't allow me to even bind that port, right? So because it's below 1024. So just in case, we're going to use 69 instead of 13. All right, so let's try to compile this entire thing and see how miserably it fails. Maybe it doesn't have to be sized. Maybe, oh, okay, so that was fine. That was totally fine, actually. Okay, so interestingly, so you still have to create a socket. I thought maybe acceptor automatically creates a socket for me, but no, for the server socket, you still have to create it. So acceptor and socket are two different objects, which is kind of weird. So I didn't think it's particularly gonna make a lot of libraries, they just like merge them together. Oh, no, this is not correct. This is because you accept, this is a client connection. This is a client, so okay, so that makes sense. That actually makes sense. And so in here, what you do is you create the socket, you allocate it on the stack, and you initialize it, obviously, right? So, and then using the acceptor, you accept le socket. You accept le socket. And then, yeah, so we just create a message. And then what you can do, I suppose, at least judging by just this thing, yeah, you can just write into that stuff. Asio, write. I'm writing into that socket. And I have to create a buffer out of that message. Can I just inline this entire thing? Or can I do something like this? Hello, right? So look at that. I wonder if there is a variant of write which just accepts an array of characters. And also here, they're accepting error code, but they're ignoring it. But I know from the basics and introduction is that there are usually variants of functions that don't accept error codes, and that means they just throw exceptions. So if I understand correctly, this should just work, right? If all of my expectations about the library met, this should just work. So let's give it a try. Let's try to compile this entire thing. And this is going to accept connection only once. It is going to accept connection only once, and it's going to say hello, right? So this is what I expect in here. Let's freaking go. So my expectations were not met. No matching function call stream socket. Okay, so I fucked up something about TCP socket, and this is because I'm supposed to put IO in here. That's understandable. But what else do we have to say? Okay, so acceptor has no declared in the scopes, and this is because I called acceptor server. That's understandable. All right, what else do we have in here? Right. So, and no matching function. So there is no such matching function, unfortunately. So here is that. No matching name type. So there's a lot of different variants. Can we go into this, all of these variants? Can we go into all of these variants and just take a look at them? So there's thing that accepts buffers, iterators, completion condition, and error code. Okay, this one accepts error code. Right, so this one, so accepts some sort of a constraints. Some sort of a constraints. So I want to find the one that just accepts the write stream and the buffer and nothing else. I wonder if such thing doesn't seem to be exist. Such thing doesn't seem to be exist, and so there's a completion condition and there's an error code. All right, so maybe we have to provide error code because I don't see the one that doesn't accept error code. Anyway, so where is the ignored error code? Here it is. So I'm gonna put it in here, and I'm gonna put it in here, but it may still not compile. So you say that hello may work. Okay, so because it's Yeah, okay, so maybe it accepts some sort of an object, and here we're kind of creating that object with this value passed to the constructor or something like that. That's what she suggested. Right, so, but it may not work. Yeah, it didn't work. Okay. So, but why didn't it work? Yeah, so it's still, such thing doesn't exist. So let's do that without this thing, and let's just use the ignored error code. So the error code kind of needs to exist in here. Let's see if this variant works. I kind of suspect that it may not work. Okay, so, and this is where you may try to maybe put curly braces, and this is where it may work actually. Still didn't work. Okay, so we can try to do the following thing. So apparently I have to create a message. So this is going to be hello. Okay, and in here I have to create the Asio buffer. Asio buffer message, and only then hopefully it will compile. And it did. Okay, and here is the interesting thing. What if I inline the C string literal like that? Will that work with the buffer? Okay, it worked. So apparently buffer may not be even constructor. Here's the thing. So this is a very annoying thing about C++, is that I can't tell, is that a constructor or is that a function call? It's a function. Exactly. That's the problem with C++. You never fucking know. You can see a piece of code and it can be 10 things, 10 different things. So, and you may not even know until you go and look there. So that's the most annoying thing. And this is why, like, I really like working with C, is because you look at the code and you know exactly what it is, right? So you know exactly it's a function call. In C++, you don't know. It can be anything. Actually, this could be already instantiated object with the operator parenthesis overloaded. Seriously, this could be already an object, and you just like this is overloaded operator. Could be macro, right? So, and macro, I mean, it's namespaced, but who knows? Anyway, so let me see. This is kind of an annoying thing about C++. So I can go into Asio, which is okay. So how can I go in here? Asio.hpp or buffer. Okay, so there's at least that. So do you have, okay, is this a class? It's not even a class, just a buffer. So we probably need some sort of, is that a struct? Or is that a, const buffer. So Asio buffer and code. It's a function. I should start like placing bets on things, like so like a prediction to the chat. Like, what do you guys think? Is that an object? Is that a function? Is that something else? Right? So we need to place bets on these kind of things. So anyway, it's a function, and it returns Asio mutable buffer, which is like, yeah, okay. So there's a lot of things. So I remember somebody said that C++ is kind of a language for creating DSLs, right? So each individual library is it's kind of like its own domain-specific language, and C++ provides a lot of mechanisms for like basically creating your small sub-languages, right, in C++. And I think it kind of checks out. Okay, so which also raises the question, so since this is how you always have to supply this buffer anyway, maybe there is still some variant without the ignored error, but with just that, which just throws an exception? And yes, there is. Okay, so the whole problem was that, like, if you pass in a buffer, you must create that buffer with this function. So that was the entirety of the problem. You just must create it with this function. And I suppose if you want to work with Asio, it's better to do that within some sort of an IDE, which can analyze the Asio, the headers, and just like let you jump there and stuff like that, right? So doing that in a text editor is not particularly pleasant, as you can see. So anyways, let's actually try to run the whole thing, right? So I'm going to do print ln, listening to 27001. And this is the port, right? So this is what we're listening to. Okay, so, and yeah, maybe I should just, daytime server, telnet, localhost. So 001, 6969, boom, too many arguments. Oh yeah, so because absolute budget. Cool. So we managed to create this kind of thing. But all of that stuff is synchronous. It is fucking synchronous. How can we even do that in an asynchronous manner? And I do know that the next tutorial is how to do an asynchronous one. But since I know that there's always kind of a synchronous variant of all of these things, it raises the question, can we just ourselves transform that into an asynchronous program without any special help? This is a really interesting question, right? So this is a synchronous variant. Can we transform that into a synchronous one? All right, so yeah, in here, we just created an acceptor, and here, this is just a single connection. We can try to start with accepting multiple connections, right? So let's just slap a loop on top of this entire thing and see what is going to happen. So I'm going to try to compile the whole thing. So now it should accept multiple of them. In fact, I would like to just super quickly to put maybe n, and maybe since we're working over telnet, I want to use the Windows new line /r/n, right? So I think that is going to be a little bit better. Or maybe also, by the way, it would be kind of nice to print something in here, accepted connection. It would be also super nice to get some information about the connection. But I'm not 100% sure how to do that. So I can go into Asio, IP, TCP. Okay, so here is the TCP, and there should be some sort of a class socket, or maybe at least basic socket. Basic socket. Maybe basic stream socket. So some sort of information, like, or maybe some sort of a documentation that tells me how to use this entire stuff. So there's a protocol, there's a family. So usually sockets have something like a remote address or maybe peer address. I don't see any of that stuff in here. So basic stream socket, we can try to maybe open basic stream socket. So peer address. Okay, so here is the peer. Address, or maybe peer. Doesn't really tell us that easily. So is there any like a generated Doxygen documentation that we could have just like used in here? So this is tutorials. Okay, so here's the reference. So here's the reference. Okay, this is kind of cool. Maybe we could use that. So there's execution as well. Okay, so something like socket. Maybe IP, TCP. Okay, this is good. So then I go here. We found the thing. We found the thing that we can use. This is perfect, chat. This is perfect. So it contains types. Cool. Member function. Cool. Bind, cancel, close, connect, is open, lowest layer, remote endpoint, get, okay, so we got the thing, remote endpoint, endpoint type, so that's, and it's actually, so get the remote endpoint of the socket. So this is probably roughly what we want. This is probably roughly what we want. I'm gonna go in here. So we accepted le socket, remote endpoint, and we get some sort of an endpoint, and I don't even know what it is. It's just like endpoint type, but at any point we can just do auto. And by the way, yeah, so we can't really use auto anywhere in here anyway, so whatever. So endpoint EP. And can I just put EP in here like that? So if I just try to compile this entire thing, is it going to work? No, obviously it is not going to work. Saying something like in instantiation, so there is no formatter for the endpoint. You can't just do that. And endpoint, I can't really click on it, so it's not particularly accessible to me. So I wonder, so is there something like endpoint? Any endpoint? Raw protocols. So endpoints exists for TCP in here. So what I'm interested in is get an IP address associated with the endpoint. And it is just an IP address, and it's probably not printable. So that means that what I have to do is just like address, right? And obviously it's still not going to do any, like what I want, right? So because there is still no formatter for that. So what we have to do, we have to go inside of the IP address. So address, okay, so here it is. Here is the address. And inside of the address, we may have finally two fucking string. Will that work now? Anyway, let's fucking go. It said hello. Did it say anything? There you go. Accepted connection from this IP address. That's very cool. We can do that multiple times. We can do that multiple times like that. So my current local IP address is this one, right? So I can try to connect to myself using that address. So I don't really remember. I never actually specified what range of addresses I'm listening to. So I suppose it's just listening to 0000, which means that any connection, right? So, and if I try to connect through that specific address, it worked, right? So you see, depending on what address I'm connecting to, is just like printing a different remote address. Okay, so that's working. That's kind of working. So that's pretty cool. But again, all of that is synchronous. We want to do asynchronous stuff, right? We want to do asynchronous. And to prove that it is asynchronous, right? So maybe we're going to have some sort of a timer that also periodically prints something. So all network interfaces, yeah. So certain doxing, yeah, I'm sorry, I just leaked my IPv4, like local IPv4 address in the local network behind the router, right? So you can now locate which room I am in my apartment. Very cool. Okay, so I suppose what we have in here is accept async. By the way, since we found the reference, we can actually use the reference now instead of tutorials and stuff like that. So here's an acceptor. So IP, I can even just go and like do something like that. There you go. Man, this reference guide is much better than tutorials, right? So like tutorials are really good to just like get you started, right? But once you kind of understand the idea behind this library, you can just like use this thing. So there should be accept function, right? So this is the types. Here's the accept, async accept. Okay, so async accept. So start an asynchronous accept. Let's go here. So what this motherfucker accepts? It accepts the basic socket. Okay, so here is the socket that accepted by a reference. Then async token. I'm not really sure if that's what I need, but I'm looking for the callback. Is it called callback? Do you guys remember what it was called? I think it was... So it's a man, these types are unreadable. C++ people, are you okay? How the fuck do you even read that? Like, this is unreal. I'm trying to focus on this thing. Real C++, by the way. Real C++. Oh boy. So this one accepts a socket and token. I don't remember what is accept token. And this is a constraint is compatible protocol 1 blah 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 blah. So I kind of want to go back to this one. Right, so asynchronous timer. I want to take a look at the asynchronous timer tutorial. What we did in here is, so async wait, right? So this is a async wait, and okay, so it's called token. So they call that callback a token. I just forgot what they call that, right? So the callback is a token. All right, that's pretty cool. So that means in here, it's a accept token. So that's pretty cool. So, and default completion token. Like, what I don't like about this thing is that it doesn't allow me to jump to some of these things. Like, I literally have to find them somewhere. But I mean, I think we can work with that. Right, so this is an accept token. Right, and I want to know the type of this entire thing. Right, so how do I even know what kind of type I can accept in here? So that's it's a little bit of sadgia, but it is what it is. So I suspect, by the way, I suspect is that what I have to do in here is just accept. I probably literally accept a token, default completion token. Accept token, and this is a default completion token, default completion token, default completion token. So since it's a default completion token, it's probably the one that just accepts an error. All right, so here's the idea. I'm gonna try to simply do something like that. Right, so I'm gonna just try to compile the whole thing. Okay, so no matching function, that is understandable. And what we have to do in here, we have to do something like a const std error code, right? And it's going to be EC, and that should work, if I understand correctly. And that in fact worked. So, and this one is rather interesting, is that because you can't do that in a loop, right? You literally can't do that in a loop, because since that's the only thing you can accept in here, the only way you can get that socket is by literally capturing it by a reference, right? So you have to capture it. So that means if you're doing this kind of stuff in a loop, this particular socket is going to die, right? So that means, this is a very interesting like a question, right? So it's probably, you have to do all of that stuff in a completely different paradigm. So let's actually try to do asynchronous stuff just for a single connection, right? Just for a single connection. So here, so we take the socket remote endpoint, and here is the another stuff. And what we have to do in here, we have to do a write, but we probably have to do a sync write, right? So this is going to be a sync write. Okay, so let me go to a reference, and I'm going to try to find a sync write. Here it is, a sync write. And in here is just a stream, buffer, and completion token, which is just a default completion token. Right, it's just a default completion token. And I suppose we may even do nothing in here, but maybe there is a variant where you know, it's just like I don't have to like provide exception, like the completion token. Though it looks like all of the async write variants do expect you to provide that. Is there ignore function? No, there is no ignore function, but you can always kind of create it, can't you? Right, so you can do ignore token. So, and this is basically the one, std error code EC, and you literally just do nothing. Nothing. Or you can maybe, if an error has happened, you can basically log it or something. Okay, so let's try to compile this entire thing. So hopefully it will compile if I understand. Okay, so it didn't actually compile. So no, yeah. So I have to put ignore. Ignore token. Okay. Ignore le token. Okay. So no matching function. Aha. Oh. Oh, I copied accidentally. Happened. I pressed like a thing that duplicates a line. All right, so there is no such function, async write. Aha, that is fascinating. So what kind of variants do we have in here? So here's that, the buffer, and the token. But this is just like a type parameters. So does that mean that this is not what I think it is? Is socket not an async write stream? No. Oh, so you telling me that the socket has to be different. But accept, then like this thing wouldn't compile. That's the thing. All right, let me get rid of that and then compiles. So if socket is not an async write, why I can async accept, not async write socket? What's the point of that? Yeah, so async write stream is just a template argument, and it's just like it's just a name that they came up with. So I didn't think. I have a feeling that maybe the token is not correct in here. It would be kind of cool to have some examples in here, right? It would be kind of cool to have some examples, but it's a default completion token, and it's just using execution type of this thing, and that should just work. It needs a size t in the write token. It needs a size t. I didn't see it. Size t in a write token. I don't want to go into the tutorial chat. I don't want to accept the defeat. Like I want to figure it out myself, but it's not easy, honestly. All right, so it's not easy. So let me try to find. Okay, so there's a async, maybe. Let's try to find one of them. Grep async write. So there is a, yeah, so there's a lot of async writes in here, and could you put underscore? What are you even talking about, chat? Just a second, let me pour some water. Just a second. I guess I'll have to accept the defeat. Like, I literally don't know what needs to go in here, so we'll have to go into the tutorial. All right. Have to go into the tutorial. Because I literally don't know. It's just the types don't match. Size T as a O. Click on write token in reference. Oh, okay. Oh, that's okay. Thank you so much. All right. So, man, I was hoping that maybe I have to click in here, but I have to click in the template parameter. Okay, Jesus Christ, I didn't notice that. This is exactly what I was looking for, right? So this is exactly what I was looking for, being able to click into these types to explore further. It's just like I expected them to here, but they are actually up there. Okay, thank you so much. All right. So you saved me from the defeat. We don't have to go into the tutorial, right? So I want to figure it out myself without the tutorial as much as possible. Right, so that's kind of the goal, right? So I set for myself, right, as much as possible. So why did you copy it? Copy that stuff in here. So bytes transferred, and that has to be actually not here, but rather here. So which means, by the way, that we probably want to do something like this, right? So this has to be an error code, right? And this is bytes transferred. Bytes transferred. Okay. So, send transferred bytes, and we literally can do bytes transferred, error code, like this, and error, we take error code and we take the message of it, like so. So we don't need this thing anymore then. We don't need this thing anymore. Okay, so hopefully that will work. At least compile, not really work, but at least compile. So that's our goal. That is compilable, so that's pretty cool. Daytime server. Listening, and it instantly quit, because what we have to do is to run the context, like so. All right, so it's gonna be daytime server. Okay, that's cool, that's cool. And okay, so we're listening to this entire thing, and I'm gonna open it up, hello, and it quit. That is very cool. That is absolutely cool. But again, this makes sense only for a single connection. This makes sense only for a single connection because you can't just slap a loop on top of this thing. You can't just do that. So what you have to do, I suppose, is, you know, keep accepting this entire stuff. So one thing I'm thinking about, by the way, is to just do it once, and then once you accept, you kind of go in a loop, right? So you schedule another accept. You schedule another accept while responding to another thing. Right. So, and I wonder how easy or difficult it would be. What's interesting is that, yeah, can we, and so the funny enough is that we have to literally, and there's no really way to pass that socket somehow. It would be kind of cool if this async accept actually passed, like created a socket for you and passed it in here, so I don't have to allocate it in here. And maybe there is a variant of async accept that does exactly that. So I kind of saw in an acceptor, so acceptor, let me maybe copy paste this entire thing. So here's the acceptor and async accept. So there's only one async accept. So this is accept token, which is a default accept token. Endpoint move accept token. So what's that one? Move accept handler. And it's literally that. Okay. So let's give it a try. So this is that. That means I don't have to do anything like this. I have to provide IO. I have to provide IO. And so move accept. So, and this is an error code and le socket. That is very cool, actually. All right. Damn, that is, yeah, so that's cool. Okay, so, and that is literally that, except that in socket and here, and since it's actually passed by value, notice that, it is passed by value, so that means as soon as this entire thing finishes executing, all of that is going to be cleaned up, right? So if I understand correctly. So let's try to build the whole thing in here. So let's try to build the whole thing in here. Oh my god, it builds. Holy shit, it builds. And if I try to do something like this, a boom. All right, so transfer net bytes, hello is in here, and that seems to be working, that seems to be twerking. What that means, I can factor out the whole thing into accept. So, I don't know, accept maybe accept response request, and it should be something like this, right? I mean, I don't really know how to properly call this thing. Like, what would be the best name for this function, right? But I think it should be called something like that. Oh, it's interesting that it's Asio error code, but I can do std maybe, right? So this is going to be that, and so this one could be also a separate thing. This one could be also a separate thing, but I'm not really sure how to call that. Log transferred, log transferred, and we apply that like this, log transferred. So accepted connection, transferred that. Interestingly is that would be kind of cool to also have an access to the socket, and maybe async write also has an access to that socket somehow, but I'm not really sure. So anyways, so here's the server. We perform a single accept in here, and what we can do now is actually do that in a loop. The loop. We should be able to do a thing like that. Right. So essentially, we handle the request. Handle request. We handle the request. We instantly schedule another handler. Instantly schedule another handler, and then handling that request. So that's kind of the idea in here. What do you guys think? Will it work? I think it's a good idea. All right, so let's try to recompile the whole thing and see if it's going to work. Okay. Oh, okay. So it needs an access to the context, which means that the context probably should be a global thing. Is it common? Do we have any professional Asio developers in the chat? Is it common for the context to be a global variable? Because it feels like, yeah, so it's because you want to have this kind of functions in here, so it feels like it wants to be a global variable. Looks Erlangy. It is kind of Erlangy, but not really, honestly. You can think of it as an event loop. Thank you. It may throw exception, maybe. Well, I mean, since we're using a variance of error codes in here, so I don't think it's going to throw exceptions. So anyways, so here's the accept exceptions, like accept handlers and stuff like that. Okay. So server was not, this one is interesting. Okay. So that means the acceptor itself also has to be a global thing. Huh. But I mean, it's not that bad of an idea. We can also declare them static, right? So, and as far as I know, static is not really a C++ thing. So what you want to do instead of static is like a nameless namespace, right? To make it not visible, but I don't think it matters. I don't think it matters that much in C++. All right, so this is the server, this is acceptor, and yeah, then you kind of start the loop by doing something like this. And because of that, by the way, port, you have to kind of set the port in here, and maybe we can make it like a const thing, right? So we can pass it to the constructors and stuff like that. And yeah, that seems to be working. They're probably expecting a class with members for the context and callbacks. That makes sense, actually, right? So because, yeah, it's the whole library is kind of designed also to use classes, because I remember they were discussing binding, like using a member function as a completion token. Remember that? Like when we studied like on the exploring tutorials and stuff like that, they had a section about using methods of the classes as the completion tokens, and this is probably how they expect that. You're right. This is probably what they expect here. Anyways, okay. Everything seems to be compiling. So let's actually try to run the whole thing. Right, let's try to run the whole thing. And here is the server. I'm going to go into here. It responded hello. I can do that one more time, another time, another time, another time, another time. So we have an asynchronous server, right, and which can handle more than one request, and it stays asynchronous. In fact, what I want to do now to demonstrate that it is in fact asynchronous is that I want to have a timer that periodically does something, right? So interleaves with handling the requests and stuff like that. So let's go back to the tutorial. Well, we don't even have to go back to the tutorial. We literally have a timer example in here. So we can just start the timer somewhere. So we need Asio steady timer, right? So here is the steady timer. It's T, and I have to specify the how many seconds, right? So Asio chrono seconds, and this is going to be 5 seconds. Then we're going to do async wait, right? So this is going to be async wait. Maybe we can also say waiting, waiting for n seconds. size t seconds is going to be 5 seconds. This is seconds. Async wait. In here we can say something like seconds const std error code. So this is the code. Probably gonna ignore the error code. Print ln done waiting and seconds. You know what would be cool if std.println did a similar thing to Rust std.println and allowed me to do things like this. Is it possible in C++ to parse string literals at compile time? I guess it is. Right, so otherwise the formatting wouldn't work properly. So I think it is kind of possible. So I don't really know. But anyway, so this is E, and we'll probably have to do something like message and error like this, and this is seconds. Okay, so this is seconds, and that's it. So essentially what we're doing, we are we're starting the timer for 5 seconds. It does have compile time strict, not sure about it supporting list syntax though. Okay, so we're starting the timer and then we're starting the server. Right, and as we waiting for the timer, we can accept connections, and then the timer is going to fire up at some point after 5 seconds. All right, so let me try to compile the whole thing and just go through the compilation errors, because we're definitely going to have some compilation errors. I'm pretty sure about that. Okay, so that's absolute trading moment, and okay, I'm accepting connections. Waiting a little bit, maybe waiting a little bit. Oh, okay, so it's already said that. That was not particularly dramatic. Okay, let me do the following thing, right? It's kind of difficult to see it, especially for me with my vision. Let's put something like this, so it's instantly visible. Right, it was not dramatic enough, at least for me. Let's go. Okay. Okay, so I'm sending requests. So this is requests and stuff like that. And after 5 seconds, it actually handled that. So we are capable of handling requests and also having timers for periodic events, and all of that is asynchronous. Absolute budgeting. I know Kung Fu, I guess. After 1 hour and 43 minutes, I kind of understand the gist of this library. Right, so I know how to explore it. I really like this automatically generated reference and stuff like that. So that means I may try to implement an echo server. Nice library. Examples with C++ coroutines. Okay, listen, Kamikaze. I don't know C++ coroutines. And you know what I'm thinking? C++ coroutines sounds like a banger topic for a separate stream. How about that? So we're not going to go into coroutines today, but I'm going to have a separate stream where I'm going to learn C++ coroutines. And after we learn about them, we can try to apply them to Asio, which could be also application of coroutines to Asio, a separate stream. 3 C++ streams. That sounds like a cool plan. We'll see. Like, I'm not going to promise that it's exactly how it's going to be. But so far, that sounds like a cool plan, right? So, to expose things. So, all right. How can we do that? Okay, so I want to do a review. I transformed synchronous version of this, tutorial into a synchronous one fully by myself with a little bit of a help from the chat using a reference. Let's see how they propose to solve the problem that we solved. Right, so how you're supposed to do according to them. All right, so you create the TCP server. Wait. So synchronous TCP, they don't use TCP server in here. But here they're using... That's cheating? It's their own class. Okay. So I got scared first. And it is literally a class. Does it contain within it context or something like that? But anyway. Yeah, so that's exactly what you said, chat. That's exactly what they created a class where they actually store the context. They went with the OOP route. So the static connection, accept, handle request, start, accept. Okay, they literally did the same thing. It's a async accept loop, right? A handler of async accept schedules another async accept, but they also use this new connection or something like that. It accepts the context by the reference. TCP connection and TCP connection is their own thing, which is. Why is it so complicated? They have a TCP connection which is a wrapper around socket, and it's a bind extravaganza. Man, I'm so glad I didn't read this tutorial. Holy shit. So people often accuse me that, Zozin, you don't read documentation, you just chaotically jump into things and it's annoying. Fuck you. Documentation sometimes is shit. And when documentation is shit, my approach works. How about that? Like, my thing is simpler, isn't it? I think like whatever I did in here is much simpler, like, and it would be a perfect example for a tutorial. Wouldn't it? Did I make maybe any bugs in here? Like, do I have any bugs in here? It's a perfectly synchronous example. Like, it has a little bit of a global variables, but I mean, are you a software engineer or what? Are you afraid like of a little bit of a global variables? Especially for a tutorial, right? It's supposed to be a tutorial that just demonstrates how to use your thing. It's not supposed to be production ready code. You can like violate some best practices in a tutorial just to demonstrate things. So I don't fucking know, man. It's just like I'm kind of embarrassed even looking at this. What the fuck? Anyways. Oh yeah, I know your mom, the past beam is still running. It is still running, and it's been running for a long time. It's pretty robust. It is pretty robust. For those who doesn't know what I'm talking about, is a paste beam thing that we developed on one of the streams. Like I did an Erlang stream where I developed this thing. Right, so, and yeah, it's still running. Like I just run it once and keep going. So I'm gonna put it in here. So does it have a link to the stream where we developed that? Okay, so TBD link to paste beam stream. Okay. So, and this is not really daylight server, right? So this is more of a hello server, but I want to transform it into echo server. I want to transform that into echo server. So query replace daytime server, echo server. Okay, that's cool. So this is the echo server. And what we are going to say, so we need somehow read this stuff. Right, so we somehow need to read this stuff. That's the real question in here. So I suppose since there is async write, there must be what? What? Chat, what? Async read. So what do we have in here? Okay, so it accepts async read stream, mutable buffer sequence. Aha. So, and a read token. This is kind of annoying because I wanted to create this thing, and there's also dynamic buffer. So it looks like we'll still have to go into that route of maybe creating like classes and stuff like that, similar to how the tutorial is, because we need some sort of a context. But I still bash on that tutorial because that tutorial is supposed to demonstrate how to use your API in the most simple way possible. And I think for that tutorial, doing something like this would have been much better, right? So because I don't think it needs that classes, but now for the echo, we kind of need this kind of classes. So I'll have to do something about that. Anyway, so let's actually try to do the following thing. I'm going to do something like that, and I'm going to do Asio, async read, and I supply the socket. Supply le socket, and yeah, that's all of the things. And I wonder what is a dynamic buffer version 2. Fascinating. Dynamic buffer requirements. A dynamic buffer encapsulates memory storage that may be automatically resized as required. This is a dynamic array. This is a dynamic array in C++. And this looks like basically a vector, isn't it? This looks like a vector. Or string. So it wants, okay, so there is a shrink, but there is a shrink to fit. Shrink to fit. Man, we probably need to transform this whole thing into class. I don't really want to do that, but I feel like it needs to be done. My girl hates when I have to shrink to... Okay, I see what's going on here. I see. Okay, let's take a look at that tutorial, but maybe not even tutorial. So binding arguments to completion handler, using member function as completion handlers. It's kind of weird that in these tutorials they call them completion handlers, and in a reference they are called tokens, right? So read token or whatever. So that's kind of annoying in that regard. So where is the timer? Here it is, using members. So here is the printer, and this is a class, and we save the IO. Well, not really, we just construct a timer from IO. And this is a print. And we literally just use bind. So that's how we do the bind. All right, so and that's actually using std bind. Naming things hard. It is, I suppose. It is. So how should we call that class? Handler. Let's call it handler or something. We can put all of these things in here. So we can put all of these things in here. And as soon as you create the handler, so you have to handle the request. So what we're going to have in here, we're probably going to have le socket. So that's the socket, like so. That's the socket. So then we create the printer, and then we do the run. So isn't socket destroyed before? I don't think so. I don't think it is destroyed. Or is it? That's a good question, actually. So maybe it is destroyed. You know what? I feel like I need to make a small break. I already like streaming for 2 hours without any breaks, and so I want to make a cup of tea, and after the cup of tea, we're gonna try to transform it to something else. Oh, maybe I'm gonna come up with a solution without, you know, the classes and stuff like that. That would have been kind of perfect, in my opinion. That would have been kind of perfect. So we need some sort of like a temporary storage. And I think I know we can actually allocate that storage in dynamic memory right in here in a handle request, and then pass it to read. And then when we're writing it back, the writer hopefully will deallocate it. we can do something like that. Socket should be the last thing to be destroyed. Maybe there is some sort of a shared PTR inside of it. I'm sorry if it was too loud, like I hit the mic. Anyways, so let's make a small break. So you can use a simple char, just use stbuffer as the adapter. Yeah, I know that, right? So I can just allocate it in dynamic memory, right? And just pass it around and then deallocate it when it's done. Or so as Kamikaze suggested, shared pointer. So we can try to use shared pointer. It's actually a cool idea to use shared pointer. Or maybe unique pointer, right? So because I don't think there will be more than one like owner of this thing. We'll see. Anyway, so let's make some break and we are back, my friend. So I feel like we'll have to do the thing that they suggested in that tutorial that I bashed a little bit, but I still believe that I bashed it for a good reason, right? So because its goal is to demonstrate things, and it was just like doing too much stuff that I didn't really care about at the time, at least. So here we create a TCP server. Well, maybe for the TCP server, it's not really that important, all right? So, but here's the TCP connection, and I feel like we'll have to actually do something like this. What is enable shared from this? And it's something from the standard. Do you guys know what it is? So I have a lot of things opened up, so I think I should close some of them. Right, so enable shared from this. It's an intrusive reference counting. Intrusive, like I hear the term intrusive in C++ world all the time, and I'm still not sure what it means. I remember working with Wabbit, which is a WebAssembly, like a toolkit and stuff like that, and I had something called intrusive list. I managed to modify it, I managed to understand what it does, but I still don't understand what C++ devs mean when they say intrusive something. It feels like a purely C++ term. So it's making this, okay, cool, but what is intrusive in the context of C++? So C++ devs just invented some sort of term and they're throwing it around, and nobody uses that term. Like, I've literally never heard that term outside of C++. So it's a container didn't own value. Ah, okay, so C++ intrusive containers. Intrusive, like putting const in one place when it spreads across the entire. Okay, intrusive containers destructs that store objects directly, requiring the object itself to provide the necessary pointers for linking within the container. Don't understand it, but anyway. So it's currently managed allows an object T that is currently managed by shared pointer named PT to safely generate additional shared PTR instances, PT1, PT2, etc., that all shared ownership of T with PT. So enable shared from this. So it allows just use, so it slaps shared on this. So I suppose it turns the class into shared PTR. Okay, they're very fascinating. And here is the pointer and the internal one. Okay, I see. So it's shared, then you can create. So you literally create a new instance, and this is a shared pointer. Then you have an internal socket and stuff like that. So where is the container? I don't really see the container though. So this is the socket and internal socket. So the start function, there's some of that. Oh, it's a I see. It's even a private container. I guess that's what we'll have to do. So to handle it. So then we do start. Within the start, at some point, we do that. Oh, here is the placeholders. Okay, so there's different like placeholders for bytes. Oh, to ignore certain things. feel like they overcomplicated this one. I feel like they overcomplicated this one, and I really don't want to go that route. I really don't want to go that route, and I wonder if I can just make something simpler. I wonder if I can just make something simpler. So when I do the handle request, right, so here's the handle request. So async accept. Async accept, so this is a reference, but it's a part of the server, which is the acceptor. So let me close all of that stuff, right? So I have too many things opened already because I was exploring different things. So where is the acceptor? So it's here. This here is the acceptor. Okay, so async accept. Async accept. So there is a, you can do a socket like this, and there is a move acceptor variant. Oh, even without, this one is rather interesting because it just gives you a socket and it moves that socket somewhere. It moves that socket somewhere. What I'm thinking is that, what if we just had a class that would encapsulate the socket, and the buffer, something like this. So maybe something like a request, right? And it just literally has the socket, and we'll have to move it here, right? So here is the socket itself. So we should be able to, when I handle request, I will create request and then move this thing into that, right? I will move this thing into that. And in here, we can maybe have something like a string, like a buffer, or we can say this is a buffer, which is 1024 or whatever, right? So we can try to do something like this. So, and I suppose, let's make it like a public stuff in here. So this is going to be a request. And in a request, I suppose I'm going to just grab the socket. Maybe also I would love to. So I already have this TCP in here, which means that I can query replace all of that stuff with simply TCP. Right, none of that stuff is needed in here. So this one is global. Do we even use it anywhere? So that's kind of stupid. So what I want to do, I want to literally move it inside of the request. So what would be the best way to actually move it inside? I suppose accepted by our R value, right? I'm accepting it by R value, and then to actually move it, do I need std move like this? Is that how I literally move it? So this is, yes, okay, so thank you so much. So now this entire request owns that socket. Like it literally owns it. It's not like it will be facing std bat weak pointer x. Oh, you're not talking to me. Okay. All right, so in here, what I want to do right away is I want to maybe create a request with a socket, and it's not going to move this thing. I literally have to move it like that. So if, from what I understood in C++, you have to do std move along the entire chain of movement, right? So if I want to move this entire thing into the constructor, I have to do std move. If I want to move it inside of this member, I have to do std move. If I forget std move anywhere on this chain, it's not going to work, right? So this is what I remember from like C++. So it's kind of weird in that regard. So in here is sort of like a request. I can even maybe put auto in here, and this is a request. I'm not wrapping it into any smart pointer yet, right? So maybe at some point we'll do that. So this socket, and now touching this socket is actually dangerous because it is in inconsistent state, right? It's moved away, but C++ will never tell you that. It will just move object, but it will never tell you, like Rust, for example. So, and in here, one of the things we probably want to do is just like request socket. So now we have to use with a moved version of the socket. So this is the end pointer. This is the end pointer. And in here, so here's we're writing this entire thing. And yeah, that's a little bit annoying. So how should we do this entire thing? So this is going to be request, request, and I'm writing. But I'm actually accepting it not really by a pointer, right? So this is by a reference. So this is a reference. And when this entire thing is done, I should probably delete it. I want to somehow pass the pointer to the request to this log transferred. But I'm not sure if I can easily do that. New makes me feel icky when I use it. I don't know why. Maybe because you're kind of leaking memory. So you should add explicit to the constructor, otherwise the implicit conversion from socket is yeah. So explicit. I do remember that. Explicit or explicit. Yeah. Thank you so much. Surprisingly, I do remember that. Right. Surprisingly, I do remember that. So does async write have any other interesting variants that I could have exploited? So there's also async write at. I'm not sure what is that. Compose async that writes certain amount data. Oh, it's at specified offset. Okay, so this is definitely not what we need. So this is a write token. So this is that. Maybe there is a variant that accepts some sort of a user value, but it's very unlikely. It is very unlikely because you're supposed to just bind things, right? You're supposed to just bind things. One thing we can do, yeah, so you have to make use of bind and stuff like that. So in here, we can just pass request by value. And by the way, since request is a pointer, right, passing it by value is totally fine. We're literally passing it by value. So, okay, where is the, yeah, so, and we have to do something like this. So bytes transferred, we're gonna move it like that in here. So bytes are transferred. And by the way, here, I probably have to delete the request. So, and that works. And by the way, that also makes the socket leave after we scheduled async write. Remember how people complain that socket probably dies after you exit this function, which is true. And I'm surprised why it worked at all. Maybe it worked completely accidentally. But anyway, now, since we're moving it inside of some memory that we allocate dynamically on a heap, it will not die until we do delete request. So am I doing things correctly? So I suppose, yeah. And what's interesting is that by doing things like that, we're basically doing the binding, right? So we just do the binding in here, nothing particularly special, right? We just do the binding. So, and again, this is not the final code that I'm going to be doing. I'm just exploring, like, how can I organize the code? Mental deranged language. Well, it is what it is. That's the state of the modern software. What can I say? Let's try to compile this entire thing. So for a deranged industry, we have a deranged language. Honestly, in some sense, this language is perfect for what it was designed for modern software industry. It is as deranged as the modern software industry. So just like has all of the tools to be even more deranged. So it is what it is. Anyways, if I try to just do echo server, and then telnet localhost 6969, it does respond, right? It does respond, and everything seems to be fine. So I don't see any corruption or anything like that. At least there's no any symptoms of corruption. Maybe there is slow corruption and slow leaking of the memory, but the fact that we see transferred 9 bytes means that this delete was executed, and since this delete was executed, that means this object was deleted and the constructor was called and the constructor of the socket was also called, right? So that kind of makes sense. So, and we moved everything correctly everywhere, hopefully. So yeah, I don't know. We'll see. So interestingly, can I still do a little bit of a bind in here? So what if I, yeah, the funny thing in here is that if I try to turn this into a method of request, that means in the method of request, I'll have to do delete this. Okay, so C++ developers, if you have to do delete this, you're definitely doing something wrong, right? So that's the usual, like, conventional wisdom. If you have to do delete this, you're probably doing something wrong. Probably. Yeah, so make request a unique pointer and move it inside of the capture. We can try to do that. We can try to do that, but at some point, like, how do we say, okay, so after that you're done, don't do anything? Yeah, you never delete this. Some people do, but yeah, delete calls destructor, so it will be a recursive loop. Well, maybe. All right, so what I'm thinking here, the first thing we have to do, instead of write, we have to do read. Asio, async read. So when we do request socket, and what we have to read into, I suppose, into the buffer, and the buffer, right, is the buffer in here, this buffer. So then we can actually capture this entire thing. And let me grab the async read. So whatever I approach already using here, it already kind of works. And I kind of hate it, but it works. So let's actually see. So this is a read token, and read token accepts bytes transferred, right? So it's kind of similar in that regard. So, and in here, can I have auto EC and size T bytes transferred? Is that something I can do, chat? Or maybe const auto? Like, because I don't want to type this error code thing. Well, okay, I'm gonna type it, sure. All right, I give up. It's kind of too long. You can auto it, yeah, but it's too long. Auto. It's called error, maybe. Yeah, it's called error. Okay, so we read that, and we do have bytes transferred. And maybe this is something that we can put in here. So count. By the way, as far as I know, if you never really specified anything in the initialization list, the value of the count is unspecified, right? So it is not guaranteed to be 0, if I remember correctly. So you have to do something like this. Man, I remember a lot about C++. Maybe you should become like a professional C++ developer one day. So anyways, what we need to do. So now, one of the things we can do is that we can do... Oh, and this is where, by the way, we can use maybe request at, but I'm not 100% sure. So I'm not sure if I really need to have this count in here. Like, do I really need it in here? I'm not quite sure. Is it better made the default value for the member? Maybe. So it's a little bit closer to it. You're right. So I'll just keep it 0. I feel like this member is not even needed. I feel like we don't even need it. Okay, so I'm gonna remove that. So, and in here, I'm gonna do Asio async write. Okay, so here we can actually log some stuff. Println, we can say received. How do you spell received? Yeah, received bytes from this. And we can say bytes transferred, and who is that? It's the request socket So where is the acceptor? Accepted connection. So you do remote endpoint. Okay, so let's put it like that. A remote endpoint. We just query it one more time, and this is EP address to string. Okay, so received that, then we do request socket. And here's the interesting thing. Asio buffer, we can specify the same buffer again, but it's now much smaller. There should be some variant of Asio buffer that also accepts the size. There must be. So let's see. So where is the Asio buffer? Okay, so there's a copy. So what variants of buffer do we? Told you. So, and I suppose like literally we have to specify bytes transferred in here. So that's the buffer. So this is what we write in here, and then at the end we can finally do this last thing, which is kind of schizophrenic. I do understand that all of these nested things are kind of weird, but it is what it is. So I'm gonna try to maybe make it a little bit prettier after I'm done with this thing, right? After I'm done kind of sketching out what exactly I'm trying to do here. Yeah, coroutines will definitely clean this up. Yeah, coroutines will definitely clean this up. Not tomorrow, I don't promise that to be tomorrow, but at some point. So in here is the interesting thing. So this is where we can literally do delete. And because of that, I don't feel like, do I need to do shared pointers and shit like that? Do we need shared pointers in here? We'll see. So because at any point an error may occur in here, and if error occurs, we should probably also delete this request, right? We should probably delete this request. Okay, so can I just do something like this? Maybe let's put it like that. So this is going to be actually 4 spaces. This is another 4 spaces, and this is another 4 spaces, and in here this one is also going to be like 4 spaces. Okay. Honestly, that by STD bind extravaganza was not as bad as this, but anyway. So, so println, so send bytes to this bytes transferred EP address to string, and we probably want to do that EP one last time, maybe even here, and we delete the request in here. Okay, so this is roughly how I want to approach that, and I think it kind of makes sense. Like this blob, this weird blob kind of makes sense. So, and I feel like maybe, here's the thing, if we wrap the request into unique pointer, we can keep moving it into lambdas, and then if at some point an error occurs, right? So error occurs and we return out of that, the request will not be moved into the next lambda, which theoretically means it is going to be destroyed on return. So if we just wrap into a new pointer, I think it will just work, right? And we won't need this weird delete request. Yeah. So first, let me check that this works. Let me check that this works. We don't even need shared pointers because we're not going to be sharing it. It's just like one owner, and we keep passing that unique pointer to the next owner, right? We keep passing it, and it's going to be fine. All right. So let's try to compile this entire thing. Hopefully, it's not going to blast C++ errors into our face. First try. I typed out this schizophrenia perfectly. First try. People ask me, why do I hate C++ so much? Because I fucking know too much. I wish I could forget it. I wish I could forget all of that shit. Please, get out of my head. Please. Why do I know all this stuff? Anyway, so... so let's actually start this thing, and it's just like, hello? Ah, fuck! Shit! Damn! Okay. Didn't actually read shit. Fascinating. I wonder what happened. So, yeah. It just... We scheduled the read. Alright, so we scheduled the read, but we didn't receive anything. So did it do error success? So let's actually try to see. Received 34 bytes. Terminated... Okay, so this one... are you using class? No, I'm not using class. Okay, so let's try to do that one more time. I just want to see what's going on. And we connected. I sent some stuff. It didn't receive that stuff, so that's what's weird about it. But if I close the connection, only then it received 18 bytes, but then it couldn't send it back. So, do I have to, like... That is weird. So why it didn't work? So I did the read, and read literally didn't. It buffers input, doesn't split on lines. Yeah. Can we, like, how do we make it split it on lines or not buffer? Or until is composed reads data until a dynamic buffer single or okay. Until, and so delimiter goes on after the buffer, and I suppose we're gonna just put, let's put a new line in here, right? So this is gonna be just literally a new line. Found it. Actually found it faster than I expected. So, oh, okay. All right. So yeah. String view as a delimiter. Nice error message, yeah. So read until, here's your stupid ass socket. No type, name type, yeah. No matching function call, yeah, so it couldn't just come up with a function. So as a buffer, I provided you a buffer, and I suppose the buffers go, yeah, so delimiter go after the buffer, but it just like didn't accept that. But I mean, it accepts char. So you suggesting use quotes, but it says char. So you also people say read sum. Okay, read the sum. There's no such thing as read sum. So you're lying. We can try to put this thing. Okay, so that's fine. But doesn't make sense. Yeah, it's just, it didn't help. It didn't help. So let's try to, so this is the read token. So this is literally an example in here. Dynamic buffer. Yeah, that's a problem. It has to be a dynamic buffer. Is there just a regular buffer? So if I take a look at the read, just a regular read, it accepts mutable buffer sequence. Mutable buffer sequence. Man, this sucks. Why it doesn't allow me to just do that? You can just pass vector, right? Maybe. Or string. Okay, let's try to maybe put std string here. So this is std string now. So because of that, can I just put a buffer like this? Yeah, it has to be dynamic error because it's not sure when to stop. Yeah. So, and I suppose, do I have to wrap it into Asio buffers? Right, so if I take a look at this, encapsulates a memory storage. It's just a requirements. And I suppose std string fits into this. I think it fits into this. So that means I can put socket, buffer, new line. Okay, so and in here it has to be, well, yeah, it's kind of annoying. Because of that, I can just do it like that because it's going to modify that buffer. All right, so that makes sense. Okay, let's try to compile it. So because of that, we don't really need bytes transferred, but we still kind of need them for logging. We still kind of need them for logging. Oh, fuck. Man, like... You think I still need to wrap it into the buffer? Asio buffer. You still think I need to wrap it into the buffer? I'm kind of... Because it by itself is... Is there any example? Asio async read until example. Schizophrenia, literal schizophrenia, not a language. Oh my god, bro, shut up. Okay, so socket buffer. What is a buffer? What is a buffer? What is a buffer? What is a buffer? What's the definition of the buffer? Okay, so we can maybe do that. That's not a bad idea, honestly. All right, so we'll just use Asio stream buffer. Okay, and then read until. And this is a question, so that means it's not necessarily going to work. So read the description async carefully. After successful, the stream may contain additional data beyond the delimiter. Aha, so you have to. Okay, so this is a good one. Yeah. So that means. Did they use Asio buffer? Yes, I feel like they did use it. Read until. They do not wrap it. That's what's interesting. They do not wrap it. But anyway, so this is that. So this one, we probably will need bytes transferred, probably. But I'm not sure how this will play out. Okay, so I'm gonna comment out this thing for now, just to keep it simple, right? So let's just try to make this particular thing compile. All right, so what about this one? Okay, so that's understandable. No matching function, so you can't just do that. So you have to be a little bit careful, though it doesn't matter, honestly. We can just send everything. Just for the sake of simplicity, let's just send everything, whatever. And the compilation times just keep you like waiting. Buffer data, does it have a buffer data? By the way, let's actually take a look at this thing. So stream buff. Are you serious? Like using J4 makes sense when you have several translate. You're trolling, right? You're trolling. Okay. Anyways, what do we have in here? So there's a data, and it's just a const buffer. We can try to do that. That won't do much. Like we have literally one translation unit. It's one translation unit that is taking so much time. Okay, so we're just. I'm gonna send everything. We're gonna send out all the data, whatever. And here is the echo server. All right, so telnet, boom, hello. What a language, man. What a language. So, and people will 100% then tell me, you're just a C++ hater. Bitch, do you see the reality? Do you see the reality I have to deal with? And it's definitely just like me doing something wrong. For example, not using an IDE that helps me to deal with all of that schizophrenia. But anyway, so the idea that we had, right? So we need to create a unique pointer. So we need to create a unique pointer. So unique PTR. Unique PTR. Clearly not using enough templates. Yeah, exactly. So I remember that there was something like a make PTR or make unique. Yeah, I don't remember that. Oh my god. I looked away from C++ and now they have make unique for override. It's like function underscore for that specific problem that occurred because we introduced that specific weird thing in C++ 17. Yes, classic. Anyway. So it make unique, so we will probably have to do something like this. Can I just do make unique unique like this? Is it something I can do? So because of that, by the way, I can just remove that. This is not what I want. I wanted to band-aids, yeah. Okay, so it didn't work. It's not declared. Okay, so std make unique. I also want to do an interesting thing in here. I want to have a destructor. So is it safe for me to do the destructor? I think it is, because I just want to log when request is destroyed. So that's the only thing I want to do. Just want to see. All right, so that's what I want to see. So this is make unique and so on and so forth. Oh shit. Okay, so no matching. Really? So do I have to pass the object as is? So are you telling me that I have to do some... Man, that sucks. So that means I have to do std unique ptr request, and I basically have to treat make unique as a constructor of this thing. Can I... Okay, so in that case, can I just construct this thing like that? Can I just do it like that then? Okay. I should be able to do it like... Oh my god. No matching function to... Okay. Alright. std make unique. Okay. Do I have to also... Well, I mean, in that case, I can just probably do auto in here. It didn't move anything. Wait. How do I move? Do I have to... So also memory, but I mean, whatever. I didn't think it's gonna... Now we have to move stuff. No, it can't be. Dude, no. No, I don't believe that this is how it is. No. You're trolling me. No, you must be trolling me. Now it is doing something absolutely schizophrenic. Alright, so let's focus on one thing. Okay. So it didn't like something in here. So shared point, maybe we should switch to shared point, but I mean, I kind of want it to be a unique pointer. So why this didn't work in here? So something is weird, honestly. Forward it instead of move. Where though? So what's the difference between forward and move then? None of that really helps. None of that really helps. Could not capture by reference. So let's try to do shared. Let's try shared. I think shared might work in this regard. Well, obviously it worked because you can copy it, right? So in this specific cases, we're copying it, right? And shared allows you to copy. But then it's kind of weird, right? Like this feels like a little bit of an overkill for shared pointer. Since we're threading this object through all of these callbacks, shared feels like an overkill. Instead of the second closure, you should still return the first where you moved it from. I don't understand what you're talking about. Anyways, so let's try to run this entire thing. Okay, so hello, and it kills it. So as you can see, it calls the destructor. So if you purely chain in lambdas, you can get away with unique pointer probably. That's exactly what I was talking about. Thank you, Sherlock. But how? So if I change it to unique, I can't literally do that. So the second lambda doesn't work. People were saying something about forwarding, std forward, but I'm not 100% sure about that. So std move request. So that kind of solves it for an inner lambda, right? So for the inner one. Put a pointer like this. No. If it's a unique pointer, right, so the inner, I can't go through, so no move, but it's inside of this thing, chat, you don't understand. The thing is, I'm gonna be capturing this entire thing by reference, and then this function quits, and this object dies, so it's not going to work. It's on this, like I need to do that. So we got a bunch of people who have no idea what the fuck I'm doing. Okay, so I can safely ignore them. So I see no other way but use shared. So I literally see no other way but use shared. Like yeah, so that you have to do shared. Add mutable to the outer lambda. Lambda mutable keyword. Like somehow it's C++11 even. I somehow missed it. What does it do? So it basically is, there's also equals. Wait a second. I forgot about equals. Equals, it's when you want to capture everything by value. So it requires me because by default the function object should produce the same result every time it is called. This is the difference between an object-oriented function and a function using global variable effectively. So when you slap a mutable onto a lamb and onto closure, you're saying that if you call this closure several times, it may produce different results. Do I understand correctly? So that's what it means. Somehow I missed that. But yeah. Anyway, so so this one. Okay, so this is the last thing I'm trying, by the way. This is the last thing I'm trying. And if this doesn't work, I'm going with shared pointer. People in YouTube comment section, let me know how do you do that properly the C++ way. Right, so this is the last thing I'm trying. The last thing I'm trying, and I'm done with it. So this thing compiles, right? So this is unique. This is a lambda with mutable. Okay, that's cool. All right, so now I'm enabling that, and I probably, okay, let's try to do it like this. And this is not going to work, and it's going to be std move request like this. This doesn't work. I'm moving on. Okay. This language is an encapsulation of pure schizophrenia. Like, what the fuck? Ah. Okay. So, but that's kind of cool that it, like, why do I have to do all of that shit just for this thing to be unique? That's weird. Okay. Why do we need mutable here? Exactly. Is that because you are mutating this object that you captured? So by saying mutable, you're saying, okay, I'm capturing a bunch of things, but I'm also mutating them. I'm also mutating them. And yeah, which is true, by the way. I am, in fact, mutating all of that stuff. std move needs your pointer to be non-const. Ah, I see. But it's not really a pointer, isn't it? Like I'm moving it. Okay, so let's actually try to test the whole thing. Let's try to test the whole thing. So this is an echo server. I'm telnetting to this entire. Shared pointer it is. Shared pointer it is. I'm not gonna even spend any single second trying to figure out what went wrong. I do not care. Shared pointer it is. Shared pointer it is. Like, it's just like, I don't see any other way. I don't see any other way. So it must be a shared pointer. Such an overkill. An insane overkill. But maybe it's a skill issue. I don't fucking know. The hardcore C++ developers who spent their entire life studying this language just for this simple thing, please let me know in the comments, how do you do that? I personally do not care. Anyways, so let's actually remove this destructor. So we're going with the shared pointers. How could you live with a shared pointer? That's a good question. So I'm not sure how I'm going to be sleeping tonight, knowing that I introduced shared pointer for such a stupid thing. But it is what it is. So it is what it is. So what I want to do, can I actually loop through all of that stuff? I probably cannot. Right, so because looping kind of implies that I need to call to lambda itself several times, right? It's not because inner lambda constructed before the outer parameters are evaluated. Oh yeah, that is true. That is actually true. But anyways, so let me actually open several of these things. And what I'm going to do is I'm going to start the server. Okay. So, and I'm going to telnet into this thing. Another telnet, another telnet, another telnet. So I'm gonna go into here, I'm gonna put full. Okay, so that's cool. Bar, that's cool. Hello world, that's cool. We held 4 connections asynchronously. Okay, so that's pretty cool. So this is an asynchronous echo server. Asynchronous echo server. Very interesting. So, and it's a single thing in here. By the way, I didn't recompile it because, yeah, I removed the, what is it called? Destructor. I removed the destructor. So should we deploy it to urmom? Should we deploy it to urmom? That's a good question. Do I have a C++ compiler? I don't even have a C++ compiler in urmom. That's a bit annoying. I wonder, can I SSH into urmom as a root? I don't remember. Okay, I can. So can I install G++ super quick? I think I can. So I'm just installing it on a separate screen. All right, so that's pretty cool. SSH into urmom, G++. It's pretty cool. So what do we have in here? So we have a bunch of gits in here. So that's fine, I guess. So how should we call this thing? Asio probe. Right, so this is Asio probe. I'm gonna git init. Git init Asio probe git, and I'm gonna init it as a bear. Right, so using master as a name for initial branch, the default branch. Okay, so I'm not really sure what you're talking about, but whatever. Okay, so now I should be able to maybe initialize the whole thing. So I'm gonna git ignore two things in here, echo server, and in here make file time as example. So I'm gonna git ignore all these things, then git init like this. Okay, and I'm going to commit all this stuff. Ready, set, go. Okay, so can I now add an origin? So it's gonna be streamer at urmom git. I think that's where it is. So it's a git, and in here asio probe.git. So that's the remote URL. Yeah, that's the default one. Okay, so can I push that now? Is it going to work? Successfully pushed. And I can now git clone Asio probe, like so. And I do have Asio probe in here now. So I kind of deployed it to urmom. And that's bizarre. And that is because, yeah, the default branch is main. So that's weird. So status tree. So what's the current branch exactly? There's not a single branch in here. So can I fetch? That is absolutely bizarre. I have a problem that I actually set main as a default one. Git status. Didn't I do git status? Freaking, yeah, so it's already on the master. So what kind of branches do we have? So here is the main, right? I'm annoyed. I'm really annoyed. So, so here is that. Why don't I see all the branches? Why don't I see all the branches in here? Why don't I see that? You know what? Fuck all of that shit. So I'm gonna remove all of that stuff and that stuff as well. Something you didn't push into urmom, I literally did. So you guys missed everything, right? You literally missed everything. You're just saying things that have nothing to do with reality. Asio probe. Okay, so Asio probe. So this is that. I'm gonna literally SCP this whole thing. Okay, SCP echo server C++ streamer at urmom. You're an master domain because political correctness wokis waste time on the stream. Yeah, exactly. So Asio probe, and let's just copy paste this whole thing. Okay. Lost to wokeness yet again. Right, so G++, and I'm going to try to echo server the whole thing. Echo server. All right, so echo server C++. Okay, so this is going to be std C++ 23. Fuck. 20? Fuck. Are you telling me I don't have a C++ 23? Okay. Honestly, an easiest thing to do in here would be to stdio and query replace println printf, like so. Boom. Well, we're kind of doing string in here, so changing all of that stuff is going to be a pain in the ass. So you use std so many times to do have std, yes, so that's what's going on here. I just have std. Okay, IO stream println. Maybe update the G++. Shut the fuck up. All right, so let's actually fix all these problems in here. And this one is going to be std handle. All right, man, this is cancer. Like converting each and individual println to this. Okay, so I'm not gonna be doing that in this is cancer, I'm telling you. This is not convenient to do. Oh, all right. Wait a second. How do I in a string how do I do that? I remember that there was something like cdata, or like I don't remember what it was, like in a string, in a basic string. So this is a basic string. I forgot what it was. It gives you C string. What was the method? Chat, be useful at least one time. Say something useful. What was that? C string? No. C data. What was the function? C, yes. Thank you. Finally you are being useful at least once. Okay, so that's what I went in here. So what that means, I may try to transform that to that cstdio. So now what I'm gonna do, println to printf. Okay, so I'm just replacing all of these things like that. Right. Okay, so and then let's just find this stuff. This one has to be S, and this is a CSTR. Right. For now, I'm just not gonna add new lines yet. So received, this is ZU, and this is S, and this one is CSTR. All right, so that's another one. So this is ZU, and this is S. Can you see what I'm doing, by the way? You probably can't. Okay. So waiting, so this is much easier to handle, right? So because the function calls have the same shape, right? So transforming printf style into cout style is just like, it's too much effort in my opinion. It is in fact too much effort. This one is a little bit easier. So this is ZU, and this one is S, and this one is going to be CSTR. All right. So this one is the port. This is you, right? Okay, so we can try to build that now without C++23. Oh, I don't have Asio. Can I just install Asio? So SSH root into urmom. There could be a little bit of a problem that I don't have Asio on Ubuntu on urmom. One thing we could try to build it. All right, so that's one thing we can try to do. See out was a mistake in the first. C++ was a mistake in the first place. All right. Okay, so here's the variant without this thing. So hopefully I'll be able to download it. Can you just give me a direct link so I can get it on my server? Can you? Okay, so SourceForge is incapable. libasio dev. Okay, so thank you so much. Libasio dev. Thank you, Valerie. So hopefully, yeah, I already installed it. So I hope it's not a boost version. I hope it's not a boost version. Okay. It took too long to compile this thing. Well, pretty much the same amount, 4 seconds. Okay. All right. So, what's the IP? SSH config. So that's the IP. Well, wait. We have to, just a second. We have to change the port. So what port we're currently using? 6969. Let's use 6970 because 6969 is already taken. Right, so that's the port. Ah, fuck, my monitor died out. All right. So, okay. So this is the IP. The port is 6970, and I'm about to run the whole thing. It is currently running, and I'm going to do telnet, go into here. Oh, by the way, fuck. I forgot the new lines. Just a second, chat. Just a second. I forgot the new lines. Okay. Asio prop. But you already connected, guys. I saw you connecting. So let me know. Did you manage to actually do anything? I'm gonna actually disable the subscribers mode. So people who managed to connect, it worked. Okay, thank you so much. So for each individual printf, maybe we could record a macro. So I'm gonna just find the printf, then find this new line. Okay, so boom, 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 boom. I use the macro, by the way. So in Vim. So I know how to use macros in both Emacs and Vim. Absolute magic. Anyway, G++, Emacs magic. Emacs magic in Vim. Emacs magic in Vim. Okay. So I'm going to try to do that one more time. So yeah, I'm starting the server yet again. People are connected. Okay, I see a lot of people connect. Holy shit. I wish I could estimate how many people are connecting. But the fact that I can still, so the fact that I can still do things, still connect, is actually kind of cool. I got error message too fat. Yeah. I wish I could show you like everything that's going on, but it's like it shows IP addresses. I don't want to leak IP addresses. Oh, way. Huh. We got an exception, by the way. Transport endpoint is not connected. Huh. I wonder how you managed to do that. So this is what we got, chat. So the log was going crazy, and then we got something like this. Stress testing live. And what's funny is that it threw an exception, right? So it basically threw an exception. So I wonder what we can do in here. It's probably the exception was thrown. So the second message one sends makes it go burr. I don't understand what you're saying. Can you speak English, please? All right. So echo server. So my suspicion is that maybe it's because I'm not handling one of these errors somewhere. Looks like a disconnect after read. Ah, that kind of makes sense, I suppose. And by the way, so when we have some sort of an error, right? So error codes. It's kind of not convenient to actually work with this thing because I have a different version in here. So can I SCP this thing into here? Who needs Git when you have SCP? Am I right? Am I right? Am I right? Okay, anyway, so let's revert, and here are all the printfs in here. So that's pretty cool. So in here, how long am I already streaming? Yeah, so it's already 3 hours, which is fine. We're almost already done. So error code, error code, error code. Error code is a class, for fuck's sake. Okay, so does it overload something that I can use? Okay, so it overloads the boolean, checks if the value non-zero. Okay, so that's perfect. All right, so if not EP, all right, so can I now convert that thing to a string? Do you have something like, okay, so it has a message. Okay, so printf error from this while reading. So we're doing a read while reading, and then we print an error. So in here we can literally take the thing, so that an error is a p message c string, and then we just return out of that. So that's what we do. And it's actually just an error. So, and in here, I think that's literally what happened while writing. Yeah, if error. Is it really? So, wait a second. Checks if the value non-zero. Ah, fuck. Okay. So, checks if the value non-zero. Okay. So let's try to build the whole thing. Oh, fuck, lambda is no capturing. There's no message. Ah, fuck, error. Yeah, that's true. Error. Cool. Okay, so what are you saying in here? Ah, because we never... Yeah, that's true. Okay, cool. So can I do SCP back to the server? I'm SCPing back to the server. All right. I need to rebuild the whole thing. So let me double check this server. If error. So okay, so the changes were received. The changes were received. And now I'm going to do G++. I'm recompiling the echo server. And I'm starting the echo server with error handling. No, it didn't. That was not it, actually. That was not it. So I still received that error. So what other hypotheses do you guys have? So people are connecting, right? So, but then we have this endpoint is not connected, which is exception, by the way, which is exception, which is rather weird. So handle request. You know what? Maybe this is something that we're not doing. So we can do something like this. So we can just do an error. Right, so we always schedule in the next one. But I'm not sure. So error, if an error, I just return. Yeah, that is true. So if you failed here, so if there is an error in here, what is going on is that you're gonna try to do something with the socket that is not correct. So you have to do, like, you have to handle this thing, but you also have to schedule the next thing. Maybe the remote endpoint needs to be checked only if you don't error. Thank you. Okay, so error message. Okay, so error while accepting. Error while accepting. Catch. I don't want to catch, right? So because we're using variants that explicitly capture the error codes. All right. So, and I want to SCP. Right. So then I'm building. Is it the reuse flag? No, it's not the reuse flag. Okay. I'm starting it. No, it's not the case. So, any other ideas? I don't really know what could be that. So transport endpoint is not connected. We can try to Google this error specifically. So C++ says your limits on, no, it's not that. A transport endpoint is not connected. Mask the IP addresses so we can see action. Okay, but I mean it will take too much time. Exception indicate that the thrown version socket remote endpoint was invoked where the underlying call. Ah, I see what you fucking did there. It's on. Oh my god. Okay. So none of that matters. Okay. So is there a remote endpoint? I don't want to handle that, honestly. So the way you achieve that, whoever doing that, is that you connect and instantly disconnect without giving me an opportunity to even do remote endpoint, because a remote endpoint can do this kind of thing. Okay, good one, actually good one. So let's remove the remote endpoints, right? So this is probably something worth doing anyway. Right, so yeah, let's go to the compilation notes. This is not what I want. Okay. Thank you, by the way, for stress testing. Whoever's breaking the servers, thank you so much. I really appreciate it. So it's kind of fun because I'm learning things. Okay, so what's the next one? So error while reading. Okay, so error while reading. Okay, so this is an error message. I hope it's not going to expose anything from the error messages themselves. So received bytes. Yeah, we don't really need to show like IP addresses anyway. Okay. So error while writing, and we're gonna just do it like that. Okay, do we have anything else? So this is the last one. Send these bytes. Bytes. Okay. SCP, copy it in there. Probably was a netcat with -z flag, probably. Did you? Yeah, I forgot to print enter. That's the fun thing about the streams, is that somebody can do that and they don't even have to tell me. Like, we don't know who does that. So we really don't know who does that, but somebody does that and it's fun. Okay, so remote. And that person also has fun. So everybody's having fun. All right, so I'm starting the server. Let's go. I see you. I motherfucking see you. I motherfucking see you. I motherfucking see you. Yes, that was it. We won. We won. So it doesn't work anymore. You're not crashing the server anymore, my friends. You're not crashing the server. Figured it out. All you got is IPs. Yeah. So, and they're not even that useful, honestly. They're not even that useful. Hello? And, doesn't respond. Look at that. Huh. Okay, so maybe you in fact won. Huh. All right, so let's actually try to understand what is going on. Not answering, yeah, so that's very interesting. I wonder if this is because of the DDoSing. It could be because of the DDoSing, or it could be the bug in the implementation. So let's actually confirm that it is not a bug within implementation, right? So let's just do that locally, right? So it's gonna be local stuff. Right, and I'm gonna just do echo server, right? And I'm gonna just do telnet on 27.0.0.1. Hello. Okay, it is responding, so it is probably due to DDoSing. This is probably due to DDoSing. Okay, so I'm gonna try the following thing. So this is gonna be echo, and if I try to connect to this, it is not responding though. Okay, that's really funny. I wonder why though. Using shared point is too much overhead. Probably. That's probably what's going on here. And if I take a look at htop, top doesn't really tell me that much. Honestly, the echo server is not consuming that much resources. It only consumes 20% of CPU once in a while. And in terms of virtual memory, it doesn't consume that much. So, so it's a thing, but still a thing that's ready, so it can't get blocked. Maybe that's what's going on here. Okay, so I'm gonna just kill this thing, and that's bizarre. So why would it not be able to do that? So making shared point. I don't really see. Mine doesn't answer. Yeah, so it doesn't answer. So I already killed it, by the way. I already killed it. Don't worry about it. I'm not sure, like, how can you even overwhelm the whole thing? How can you overwhelm it? Does anybody have any ideas? Because, okay, so, yeah, error while, usually error while reading, so it fails on error while reading. So it means it accepted the connection. It accepted the connection, but there was an error while reading. All right. So how will that do anything? I didn't see any problem on this line. I didn't see any problem. Okay. I was piping you random. Ah, that's interesting. Okay. I quickly changed the port just to check that, you know, the application works correctly and it doesn't respond because of somebody's DDoSing. So, because I need to check that. So I'm going to change it back to the original port. Just a second. All right. And it was kind of responding rather slowly. So yeah, I changed it back. I think I understand what is going on. Somebody's just like creating shit ton of connections, right? Maybe. Connection, also connection reset by peer. Is it a fixed buffer length? It's actually not. I think it is actually not. So maybe we could fix the buffer. Maybe we could fix the buffer. And by the way, why did we need... What happens if somebody never sends? That's a good question, actually. So Asio read until fixed buffer. Is there any variant with a fixed buffer in here? So yeah, too many people getting into urmom. Yeah, that's true. That is actually true. So yeah, all of that is dynamic buffers. You see, like, that's the annoying part of it. But I wonder if you can also have, like, here's the match condition. It would be kind of nice to be able to limit it and say, okay, so stream buffer, but like limit to a fixed size. The dynamic buffer itself might need to be fixed, yeah. All right, so we managed to create a synchronous server, right? So here's the conclusion. We managed to create an asynchronous server after 3 hours of work. It works locally, and it works generally if we deploy it globally, right? So unless we have a lot of incoming connections and people constantly reset the connections and stuff like that, max size doesn't do anything. Max size of what? Where is the max size? I don't see max size. Where is it? Max size. There's no max size in here. Anyway, so I'm gonna do a sign off. So yeah, it takes quite a bit of time to figure out how to use this library in general, right? It takes quite a bit of time to figure out how to use the library in general. And like the naive approach requires a shared pointer. And by the way, their example also requires shared pointer. They were also using shared pointers in the asynchronous example and stuff like that. And it's not particularly robust, right? So because it's so easy to just like spam reset the peer, and it kind of like blocks reading and writing. And maybe I'm doing something incorrect in here. It might be actually doing something incorrect in here, but yeah, doing the most obvious thing produces not the most robust echo server. So yeah, it's kind of a mixed conclusion I have in here. Kind of a mixed conclusion. But it's an interesting library nonetheless. This is something that I wanted to try for a long time. Right, and I finally had an opportunity to try it. And also programmed in real C++ once more. Chat, don't spam connections and pi random so we can test. I already closed the server. I already killed it. All right, so that was fun. That was interesting. I guess that's it for today. Thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you all on the next recreation programming session with Mr. Azusa. I love you all. Mwah. All right, this is the next day, and I asked my Discord server to DDoS the Echo server. And as you can see, people are opening a lot of connections, sending different amount of bytes. Some are small, some are big, but they can't really break it anymore. Right. So right now, the Echo server is still accessible. And I myself, today, after I had some sleep, I actually tried to come up with a strategy to break it as well. And I tried a lot of things. I tried to pipe urandom into the connection. I tried to open a lot of connections. I tried to slow Loris it, and I couldn't do anything. And now it seems to be working. Everything seems to be freaking working. But notice how it is working on a completely different port. It's not 6970, it's 6971. So here is the hypothesis. I'm using a hosting which has automatic DDoS protection. Right. So, and I know that about it because it fucked me up in the past several times. So to the point that I had to disable it. So this time I looked into the dashboard of my hosting, and this is what I saw. So they use something called Plex X DDoS protection. I don't really know what it is. Maybe it's their own thing. Maybe it's a well-known thing. But in any case, so it's specifically designed to protect game servers that goes beyond conventional approaches. Instead of reacting to an attack and redirecting traffic, our protection solution is constantly active and analyzes traffic in real time. As soon as a specific traffic pattern detected on an IP address, for example for these services, the system automatically applies optimized filter rules for respective services. Unknown or suspicious traffic is constantly blocked. So a special advantage: already validated connections remain intact even during an attack. This means that your players will not be disconnected from the server when a DDoS attack is occurring. And also they have a panel where they have the rules of this Plex X system, and one of the ports that was added automatically there is 6970. So what I did, I just switched the port, right? So, and now, as you can see, people are spamming a lot of things and everything's fine, right? And my hypothesis is that this was just the DDoS protection of my hoster, but maybe it is not. I have no idea, honestly, but I tried very hard to break this thing and I just simply couldn't. So yeah, I'm gonna call it a day. I'm gonna obviously publish the source code that we developed on the stream. I'm gonna put it on GitHub, and if you find any flaws in this specific server and know how to reproduce this DDoS attack, please let me know in the comment section, or maybe submit a pull request or stuff like that. So that's it for today. Thanks everyone who's watching me right now. Really appreciate that. Have a good one, and I see you all on the next recreation programming session with Mr. Azozin. I love you all. Mwah. Oh, it's not Plex X, it's Plet X. Whatever. I'm so done. I'm so done.